Today we'll be doing problems on what we have been doing in the last 2 days. Okay. EMF, terminal potential difference, series and parallel grouping. Based on that, we are going to do exercise and problems. Exercise means the questions are going to be simple. Problem will be slightly challenging. All right. These children are still entering. All right. Children, you should come on time. I'm going on admitting you people and not able to start the lesson. Chinmay, every day you're coming late. Huh? Yes. The first problem, look at that. There is a cell of 24 volts EMF and 12 ohms internal resistance. There's a key there, K. When you close it, the circuit completes. When you open it, you break the circuit. When K is closed, find the change in the reading of the ammeter. Unless mentioned otherwise, ammeter is supposed to have zero resistance and voltmeter is supposed to be having infinite resistance. This we have talked previously also. All right. Now we need to do that. Once you close the key, what difference you see in the reading of the ammeter? Okay. Any ideas, children? Any ideas? Okay. Before the key K is closed, can you not see that 12 ohms and 24 ohms are in series? The 12 ohms of internal resistance and 24 ohms of the external resistance are in series. I told you already, all the time it will be like that. Isn't it so? The current now will be I equals 24 divided by 24 plus 12. Where does it come from? I equals EMF by R plus R. A single circuit. And one resistance is there. So you got it like that. So how much is this?
2/3, sir.
Just 1 second. Children are still coming. Satvik Kasreddy, why are you joining so late? Huh? No, you people coming like that, you are obstructing the lesson. Okay, 24 divided by 36. How much is it? 2/3 amperes. And all this 2/3 amperes will flow through the ammeter, will it or not? Because the circuit is a simple circuit like this.
Yes, sir.
This one we have the ammeter. Now current will flow like this. How much is this? 2/3 amps. Now once you close it, what's going to happen, children? Even that branch will come into circuit. So how are these 24 and 24 connected, children? If I draw the figure again, I don't want to spoil the problem figure. So every time I'm drawing more and more figures. This is ammeter, it's like this. So once you connect that, current will divide like this, isn't it? So this 4, so not this 24 and this 24 are in parallel or not?
Yes, sir.
So what is the equivalent of 24 and 24? 24 by 2. 1 by R plus 1 by R. Anytime you got equal resistances, however many you have, just divide the resistance value by the number of resistances in parallel. 1 by 24 plus 1 by 24, 2 by 24 equals 1 by RE. So RE equals 24 by 2. So 12. And this 12 and that 12 in series again. So the new current from the cell is how much? Tell me.
24 by 24.
24 by 12 plus
12
12.
plus
How much is this?
1 ampere.
1 ampere. So what is the difference in the readings of the ammeter? Previously it was 2 by 3. Now it is how much? 1. Isn't it so? So the difference is what? 1 minus
1 by 3.
2 by 3. 1 by 3. Is it correct? No. This 1 ampere will divide into half here and half here. Previously, all that 2 by 3 was flowing, but now only half flows. That's a simple trick in the question. Isn't it so, children? Siddharth.
Yes.
Hey, why did you fall silent? Come on. The current now divides in parallel resistances. Current divides in the inverse ratio of resistances. For series and parallel, some 5 points for this, 5 points for this. We have given already. So this answer is not correct. Okay, this is not correct. So now previously the current was 2 by 3. Now the current is half an ampere. So the change is half minus 2 by 3 or 2 by 3 minus half, because we want only the number there, right? Right, like that. 2 by 3, now half, whatever it is. How much is that? 2 by 3 minus half.
1 by 6.
Are you there? Everybody, why don't you speak?
Yes, sir. 1 by 6.
So there's a small trick in the question. Isn't it so? Huh?
Yes.
People are not.
Yes, sir.
Have you got the trick to the question there? That's where the moment you got that 1 ampere, you will be eager to put that answer straight away. I hope everybody followed this question. I'll go for the next question, children. Huh? Tell me.
Yes, sir.
Yes, sir.
Look at this question again. I look for your suggestions as well. Find the value of R. What shall we do? Children, between those 2 points, which I did not name, I've got 30 volts potential difference. This one, I'm drawing the figure again. Why am I doing it all the time? What is there in the problem and what you suppose You should not mix up. This is 30 volts. So if I call these points as A and B, for example, this potential difference here is 30 volts. Probably you may have connected one cell there. And between these 2 points, C and D, if I name them, for example, the potential difference is how much? 5 volts. This is apparently 60. This is 48, and this is R. So, any idea, children? Kaushik Murray is coming now. Kaushik, why are you coming late like this? Huh? Kaushik. No, I'm going on admitting you people all the time. Lot of time is wasted. Now look at this. Any suggestions? Please, Icon, are you there?
Yes, sir.
Any suggestion? Any suggestion from your side? Look, tell me.
No, sir.
No. Sushma has entered now. Why, Sushma? What is this going on? I'm going on doing this. Sushma. Now look at this. This one. This one and this whole, are they in series? Tell me.
Sure.
Think so? If supposing current entered like this, it will divide like this and go like that. 48 and R are in parallel, no problem. Are in parallel. But equivalent of 48 and R, which is how much, if you can directly write?
48 R by 48 plus R.
Yes, 48 R by 48 plus R. Isn't it in series with 60? Huh?
Yes, sir.
Yes, sir.
And in series, does potential divide? Tell me. In series grouping, did we not say potential divides?
Yes, sir.
So if it is total 30 here between A and B and 5 here, how much will be across this? 25?
Yes.
Yes, sir.
But therefore, current in 60 will be how much? 25 by 60. Huh?
Yes.
P equals IR, Ohm's law.
Yes, sir.
Then I in this one, how much? 48 R by 48 plus R. Same thing, isn't it? Because this and this are in series. So whatever current flows in 60 should flow in the whole combination. Combination of what? 48 R and 48 plus R. So same current I'll put in this. 25 by 60 into R. IR equals, according to the question, 5 volts. So this is such a simple question, try to understand. But once again, the application. The application is the most important thing, try to understand. If application is there, you will at least use the created knowledge already to some better things. And also not only that, you can also create new things. So solving problem is that. And we have not used any new idea at all here. The same, like when I was discussing that series parallel grouping, I was just going on talking again and again, so that the points sync. In series, potential divides, current is same. In parallel, potential difference is same, current divides. So these two have to be kept in mind all the time. So what could be R? Did you solve?
16 ohms.
16 ohms. That's right. So R is 16 ohms. That is the answer. Okay, children, shall we continue?
Yes, sir.
Hope you're all following. Harshini, are you there?
Yes, sir.
Nishita,
I'm there, sir.
are you following the questions here
Yes, sir.
clearly?
Yes, sir.
Okay. Next problem. Come on. There are two batteries, 24 volts, 24 volts, like that. Apparently, they're connected, you can say in series actually, even for batteries, even for cells, we'll have things like series and parallel, which I'll be discussing soon. But without that formulas and all those things also, you can still try this question. Supposing batteries are sending individual currents, the currents would go out of plus, join into minus, isn't it, for a single cell? Do you follow my point?
Yes, sir.
Huh?
Yes, sir.
So it's not so difficult here, because both the currents, the individual currents would be flowing in the same way here, isn't it, towards left in the circuit. So the net current also will flow in the same direction. Do you follow my point, children? I made one statement here. Like if a single cell is there, we always are putting a current direction like this, isn't it? Huh? Were we putting
Yes,
it
sir.
like that or not? Conventional current, I. Huh?
Yes, sir.
Now, if I have one more cell connected this way, for example, don't ever write current of this separately and current of this separately in a single loop like that. There will be net current. You cannot say electrons because of this will go that way, this that way, and one group goes that way, the other group goes way. You should not say, because after all, there are only one group of electrons in the wire. So they will be pushed by this and that, there will be net current. In case this is 6 volts and this is some 12 volts, you can say this, the 12 volts will dominate. Like this. That means in this cell, the current goes from plus to minus inside. So for any cell, individual cell, current goes from minus to plus inside the cell. Are you listening to me?
Yes, sir. Yes, sir.
Is that idea sticking?
Yes, sir.
Current direction all the time, remember this way. For a single cell, plus, out of plus, into the external, and then joins at minus. Inside it goes from minus to plus. Inside the cell, the current goes from minus to plus. But supposing this is joined with 12 volts, what's happening, children? Huh? Current inside 6 volts is going from plus to minus. You should not say this current will be individually flowing. They cannot. There will be only one group of electrons in the whole conductor. So those electrons will be pushed either this way or that way. If the EMF of this is more, they'll flow in the direction of the EMF of this current. Electrons opposite it, of course. Okay, but this problem is not there in our. No, what I was trying to tell you was, if current is flowing from plus to minus inside a cell, the terminal PD of that will be greater than the EMF. Look, I want you to understand this carefully. After doing Kirchhoff's laws, it will be easier to follow, but even without that, if you can follow, that will be a good idea. If a single cell is there, if this is 10 volts EMF and some 2 volts internal resistance, if this is 8 ohms, what did you write the terminal PD as? 10 volts divided by 8 plus 2, 1 ampere is the current. Huh? Utkarsh. 1 ampere is the current. So terminal PD will be how much?
2.
1 into 8. I need to calculate the terminal PD. 8 volts. So this 8 volts is less than 10 volts. So for a single cell, we could always say this. But in a combination of cells, when current is flowing inside a particular cell from plus to minus. What is this? Plus to minus? In a direction opposite to the direction it would have gone if there was a single cell. The terminal PD can be greater than EMF. Terminal PD is, after all, the potential difference which appears across the terminals, not the original potential difference formed as a result of the chemical reactions I told. Can I believe that you got this point? This problem is actually simple, remember, not so difficult. But taking this as an excuse, I want to discuss something more. Tell me, Bhavana, did I make myself clear?
Yes, sir.
What is it? Tell me. The problem, don't worry, it's not so difficult. But I was trying to tell you something without actually using the Kirchhoff's rules. After that, it becomes very simple. You don't have to bother about all this. You apply those laws, they'll give you the results. So what is that I was telling you here? Just tell me in one sentence. Quick, make it fast. Yes, somebody else? Anurima? Are you there?
Yes, sir.
Tell me, what is that you followed here? Quick, make it fast.
It is that when current flows like from the positive terminal to negative terminal, the terms,
Inside a cell, if you say.
yeah, then
Outside?
potential difference, terminal potential difference would be less than the EMF.
Oh, no. You exactly told the reverse. That's where I was worried. If inside a cell, current flows from plus to minus. Inside a cell, if there is a single cell, it flows from minus to plus. I'm trying to get that view, that point across to you. Tell me. If a single cell alone is present, current goes out of plus, reaches minus through the external resistance, and inside the cell goes from minus to plus. But if this cell is connected to some other cell of higher EMF, the net current in the loop, you cannot talk of individual currents here, I told you. Why? The electrons, the metal only are pushed this way, that way by the two electric fields of the two cells. So there will be finally a net motion of charge. There cannot be electrons of this cell, electrons of that cell. That, I think, still you got that point in your mind. That's why people are not catching it. The cells are not tanks of electrons there. Cells are not pushing out any electrons of their own. They're actually pushing the electrons of the conductor. So electrons of the conductor are pushed this way, that way by the two cells. So there will be net motion of charge. There will be a single current here, not two currents. But when 12 volts is greater than 6 volts, that will send the current in its direction. It will dominate over the 6 volt cell. Now what is happening? The current is flowing from plus to minus inside 6 volts. In this kind of cases, I was telling you, the terminal PD is greater than EMF. That will show. In fact, it can be E plus IR, not E minus IR. Terminal PD you are writing as E minus IR, which was IR, right? Previously. But in such cases, it will be E plus IR will get. A mathematical way of looking at it will come soon, but deliberately I brought that here because even that is important. Sometimes if you put a sign wrong in mathematics, that will lead you to wrong answer. But apart from writing mathematics, if you can look at it for a while, you'll know, oh, I shouldn't have done this, I should do this. That kind of a thing happens. So please, one of you confirm that you followed so that I can move ahead. Sidhu.
Sir, followed.
Clearly.
Yes, sir.
Why, Anirima, you told me exactly the opposite?
Sir, I was confused. Sir,
Yeah.
now I followed it clearly.
You really?
It's clear now.
Right. Now, in this case, will that problem arise here? Because both the cells are connected in the same direction, isn't it? The currents of these two cells will flow this way only. So this problem, we don't get it. So when I said voltmeters reading is 0, what do I mean by that? Terminal potential difference reading is 0. Terminal potential difference reading is 0. Am I right? Tell me, children. So the total current I can write as I equals 24 plus 24, 48. I can add. They are supposedly in series. That means I can replace the two cells by a single cell of 48 volts EMF. In this case, if you are wondering, that will be a single cell of 6 volts in this direction. Okay, 48 by, what is the total resistance here, children? R plus 2 plus 4. How much is this? Okay, nothing. 48 by R plus 6. Now the voltmeter reading is 0 means E minus IR is 0 for 24. That is 24 volts minus I. 48 by R plus 6 into small r is how much? 4 is equal to 0. So R you should be getting. So this simple question is an excuse for us to understand few things about the EMF on terminal PD once again. So how much is R from there? But in case you did not follow a particular thing there, you tell me immediately, quick. Himanshi, are you there today?
Yes, sir.
How about this equation I've written? Is it okay for you?
Yes, sir.
What
Yes,
is that? What is that thing I told you in this problem basically? What is that idea? What is the idea in this problem? This problem deliberately I've given it simple, but I told you it could be something like that on the right hand side.
Yes, sir.
Okay. How about other children?
Sir, why
Raja.
TPD it is 0? Why TPD is 0?
Why TPD 0? Could somebody answer it? Himanshi, you only tell me.
Potential difference is 0.
Array, voltmeter reads 0, we said. And what is the definition of terminal PD, Varshit? The potential difference across the terminals of a cell when a current is flowing in it. Is current flowing in it now? Varshit, speak, children.
Sir.
So I am applying the definition of terminal potential difference. What am I doing?
I'm not understanding.
Array, see, this voltmeter reads now, doesn't read EMF because current is flowing inside the cell. It reads terminal PD.
Oh,
Array, that's what we have done yesterday.
yes, sir.
That's the reason I told you to watch the video again. Actually, in Delta, many times we tried previously also, but it never happened because that was in too many GBs and we stored something. The whole idea is we wanted to record and play back the video. Here I'll be putting only a few videos. I won't be putting all these videos for everybody there, but I'll send you separately. Just for the sake of it, I'm putting few videos now on the YouTube, but there's no need to put everything there. I want you to watch that thing and make your notes. I told you I'll be changing the whole game forever because your job has to be over in the class. Many people keep talking to me privately. Sir, now how should I manage my time? Because so many things are there. This one, that one, this one. Though we keep telling them some trick or the other to console them, we know in our minds, if in first year you missed a particular kind of learning, that will keep haunting you forever. How good students manage their time, you need to understand that their effectiveness of working is more. And how does the effectiveness of working come? The classes cannot become some information pouring sessions. The class is so important. Your 50% of the job, I say, more than 50% of the job should be over in the class. Actually, you should never say, sir, give me more sums, I'll get meaning of it. No need. If you followed it, you'll apply it directly. We'll give you assignments, we'll make you do, but finally, that kind of a thing, like I'll do some 1,000 questions after which I'll become thorough, is meaningless. If you're doing some 10 questions, you should be becoming thorough. That's the efficiency is like that. So here itself, some final points are discussed, for example, and they did not settle. So this time is wasted and you'll be still confused. I want one of you to really put the record straight. What's happening, please, I can you tell me now. Quick, make it fast. Whatever I've talked, you need to tell me.
Sir, right side of the problem, sir.
మొత్తం నేను సమ్ చాలాసేపు మాట్లాడినా కదా బట్ బిఫోర్ దట్ వాట్ ఈస్ ఆర్ ఫ్రమ్ హియర్
2.
నో వాట్ ఎవర్ యూ ఫాలోడ్ సాయి ఓవరాల్ గా
Sir, when we have cells of two different potential difference,
EMFs don't call potential difference.
EMFs, then current will be in one direction, sir, because ultimately the current is produced due to the motion of electrons inside the wire.
Inside the conductor wires, in the resistances, right?
So current will not have two different directions.
No, we don't have two currents from the same. Of course, we'll have two currents if there are two branches. There is only one loop. You should say in one loop. Not in one loop. Actually, in one line like this. It is not current is not dividing anywhere into another branch. Okay. You're not clear. That more than this answer, I want that whatever speech I gave to be clear. I'll go for the next question anyway. You talk to me later because you're falling behind. Of course, simpler questions here. Tell me. These are all very simple questions given now. Just find out the equivalent resistance. To find the equivalent resistance. Anytime RAB, when something is asked, what does it mean? Will you say it is 8 ohms because between A and B 8 is there? Children, you cannot. What it means is, if I connected a cell across A and B, for example, how much, what value of a single resistance, not how much, what value of a single resistance will send a current to the cell as this whole combination? What single value for cell resistance, like if it is like this, between A and B, I'll connect one R, which I call as RE. So the current in the cell when RE is there and the current in the cell when all these branches there are same. That's what you mean by equivalent resistance. Now, when you connect a cell like this, think of dividing the currents. As soon as they enter, they divide. So in this branch, the top branch, current is not dividing. Here, in this one, the current is not dividing. Once it divided like this, here it is not dividing. So can I say the 6 and 6 are in series?
Series, sir. Yes, sir.
6 and 6 in series will be 12. Isn't it so?
Yes, sir.
But this 12 now will be in parallel with 6. Don't say 1, 2, 3, 6 are all in parallel at one go. Every time when you are finding out the equivalent resistance between 2 points A and B like this, start from the other side of the circuit and keep pushing that whole thing to the points between A and B, to that between the 2 points, to a space between the 2 points. So current entered like this, 6 and 6 are in parallel, series, and 6 and 6 will give you how much? 12. 12 and 6 are in parallel, current got divided. I'm not drawing many pictures here. That looks easy in the minds, but I don't want that. Simple questions actually you need to do without writing much. Is it okay, children? 6 and 6 are in series. Do you agree?
Yes, sir.
And that is 12. 12 and 6 are in parallel.
Yes, sir.
12 and 6 in parallel, how much? 12 into 6 by 12 plus 6.
4.
4.
4.
Once again,
4
this
and
4 and this 4 are in
Series.
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 How much?
8. 8 and 8
8 are in parallel. How much? 4.
4.
4 and
4 are
4.
in series. 8.
8.
8 and 8 are in parallel. How much? How much? 4. So the answer is 4. So you should not do a lot of calculations for this kind of questions. Any specific question here you want to ask? Children, quick. All right, let's go to the 5th question. Inside, Kiran, could you
Sure.
tell me? What shall we do? Simple questions are very, very important, because in a simple question, the focus will be on the basic. In a complicated question, complex question, basics plus the connection of those formulas and visualizing the situation, so much is there. So what is basic we may miss. So that's the reason we need to take in the beginning some simple questions, but where the concept will be projected. Tell me, what should I do here? Are, why don't you speak, children? Now, if I tell you that, it will be just over in a jiffy, and what is the point? Okay, these three resistors are in series, right? So the answer is 3R, R plus R plus R plus R, that is 3R. Is it okay? Hello, are you there?
Yes, sir.
Yes, sir.
So the answer is over, right? No. They are in parallel. Now follow the method. You think this is at V, this is at 0. If you connected one cell across these points. So is it not an equipotential path? There's no resistance here, right? So all this,
Yes.
so this will be V here, this will be V here. Isn't it so? Tell me, children.
Yes, sir.
This is 0. So this is at 0. All this is equipotential path. So all over this it will be 0. That means here 0, here 0. So now see the potential difference across the resistors. V minus 0, that is V across this. V minus 0, V across this. V minus 0, V across this. So all are in parallel. So 1 by RE equals 1 by R plus 1 by R plus 1 by R. RE is R by 3. Tell me, children, what you need to understand is that not just remembering because somebody told some time ago. That will be a dangerous thing. So when I said 2R, why did not object 3R? Have I not told you already? Series parallel has to be viewed in terms of the currents and potential differences. No other way. Okay?
Yes, sir.
So when I wrote 3R, you simply nodded the head. My life becomes difficult if you don't respond, because when I discuss something, I thought you already got it. So I'll be using that somewhere. No, after the end of the session, you should have known how will I decide series and parallel finally. Isn't it so? Anyway, I'll continue. Another simple question. Another simple question. Come on. So where will you start looking the circuit from? From the cell. In a single cell circuit, that's the best method. You can think of a current going out of plus and then dividing like that. So can I do it without writing much, children? But you need to listen, otherwise you'll miss it. Now look at, I'll point. From this cell, current will come out like this. Any problem with this? It will go like this, but divides here and joins here and comes back. So all this branch
Is parallel to 20.
20. But within here, the current was dividing into these three. So all these are in
Parallel again.
and in series with this. Their resistance is in parallel with this. The whole thing is in series with the internal resistance. The whole thing. If I reduce all this to 1, a single resistance will come. That single resistance will be in series with 2. That's why you write I equals E by R plus R. So tell me, I can write in this problem once again E by R plus R for the whole circuit. I is what? Current through the cell. So let me find out the equivalent of the things like this. For these three, I'll find the equivalent first. Say I chose my numbers with a plan. So it is not difficult to calculate. 12 and 6 and 4 are in parallel. Instead of adding 1 by R1 plus 1 by R2 plus 1 by R3, take 2 at a time. 12 and 6 in parallel will be how much? 4. How? 12 into 6 by 12 plus 6. Are you listening?
Yes, sir.
Yes, sir.
One of you give a little feedback, otherwise I won't be knowing whether the connection is there or not.
Yes, sir.
So first what did I do? I reduced 12 and 6. 12 into 6 by 12 plus 6 is equal to 4. That will be parallel with 4, another 4. So 4 by 2 actually straight away. Isn't it?
Yes,
Yes,
sir.
2. 2 and 3 will be in
Series.
series.
5. 5 and 20 in
5 and 20 will be
Parallel.
parallel.
So 5 into 20 by
5 plus
and 4 and 2 will be in series. That is now we come here. I
12 by
12 volts divided by R
6
4
ohm.
plus small r 2. Is it okay until here? Tell me, children. Any calculation mistake would be there? Just tell me.
no, sir.
No. So this 2 amperes would be dividing, right? Huh?
Yes, sir.
We want the current in where? 6 ohms. 6 is where? In the middle of 12 and 4, you see.
Hmm.
So current in that I want. There are two ways of doing it. One way is this. This 2 amperes we shall divide. It goes, this will divide into this and this. This is 20. Whole thing was how much, children? This whole thing. 5. So 20 and 5. Current should divide in the ratio 20 here, 5 here. 4 is to 1. I repeat, this is how much? Tell me.
5.
5.
Sir.
So 20 and 5 are here. I'm not going to draw too many pictures. That's such a waste, actually speaking. This is all 5. This is 20. So 2 amperes coming from here should divide into this and this. How does it divide in parallel? Current divides in the inverse ratio. What is the resistance ratio? Tell me.
4:1.
Resistance ratio is
4:1.
20 and 5 we have. This is 4:1. Right? The current ratio should be what? 1:4.
4.
So 2 into, for this 5, this part, 4 by 5. Sum of the ratios. How much is this now? 8 by 5. You know, where is 8 by 5? Out of 2 amperes coming out of this. 8 by 5 will go into this. And how much will go into this? 2 by 5.
2 by 5.
Isn't it so? So total is how much?
2.
2. Now this 8 by 5 will go here, but will divide into this, this, and this. What do you say?
Yes.
Yes, sir.
So in what ratio? 1 by 12 is to 1 by 6 is to 1 by 4 ratio. How much is this ratio? Tell me.
One is to 1.5 is to 3.
You should get
1
into
is to 3.
multiply with the LCM. Huh? What is LCM of these three?
12.
Huh?
12.
12.
12. So 1 is to
2 is to 3.
2 is to 3. Isn't it so? Children, why you to speak?
Yes, sir.
So what is the thing we require? 2 here because I wanted in 6. So that 8 by 5 should be divided as 2 by 1 plus 2 plus 3, 6. How much is it? 16 by 30, yeah?
8 by 15. 8 by 15.
8 by, okay, whatever. So that is the, deliberately I've chosen things like that to remind you the simple principles of series and parallel. Is calculation everywhere right? We just went without checking properly. Are you attentive or not?
Yes, sir.
Yes, sir.
But maybe there is a simpler way. How? Once you got the total current, which is 2 amperes, drop that IR. You followed my point? I into small r will be how much, children, here? 2 into 2. 4. So out of 12, 4 goes out inside, so the 8 appears. Plus 8 and 0 I can say here. Are you listening?
Yes, sir.
Yes, sir. Yes, sir.
So the 8 will be there across this and also across this.
Hmm.
But the 8 will divide for 3 and how much was this? 12, 6 and 4?
2.
2.
4.
So 8 will divide for whom and whom? 3 and 2.
2.
In what ratio? Direct ratio. Potential divides in the direct ratio of the resistances. So 8 into 3 by 5 for one, 8 into 2 by 5 for the other. 8 into 3 by 5 for whom? This one. 8 into 2 by for whom? This one. That means this whole thing. Okay? So
Yes.
16 by 5 is the potential difference across 12, 6 and 4. So what is the current in 6 then? V by R. 16 by 5 by 6, that is 16 by 30, which is also the value there. Tell me, children. It looked crowded. I could have gone to the next slide, but we need to keep coming back. But if you followed it, that's not a big deal. A simple looking sum, I told you, I keep telling you, has the basics completely blown up. So that they become a part of your psyche, let me see.
Sir, current there is 8 by 15 ampere.
Indra?
Current there is 8 by 15 ampere.
That's what I wrote as 16 by 30, right? Huh?
Yes, sir.
But this method of this method makes it easier. Cut out that IR from the EMF and make it appear across the circuit. That becomes even shorter. So the heading was that EMF, terminal PD, series and parallel grouping. I do not know, but I can continue. I should continue. How many are listening, following? That's your responsibility now. You're at homes. This one. Come on. Very simple question, the fifth, seventh one. Between A and B, you'll think of connecting one cell. Isn't it so? Whenever you wanted the equivalent resistance, that's the meaning. Between A and B, you can think of having one cell. So what will happen? Current, for example, goes like this. If it is plus here, plus this side and minus this side, if I put, from plus out goes current into A. After going into 5 divides, then combines here and comes back. So these two are in series, first of all, and this is in parallel with this, and all the three will be in series. Isn't it so? Huh? So once
Yes,
again,
sir.
the numbers are planned properly. 10 and 5 give you 15. 15 and 10 in parallel will give you 15 into 10 by 15 plus 10. And 6, 3 and 5 are in series. 14. Is it okay?
Yes, sir.
Now, if any mistake is done in calculations, immediately warn me. Look at 8th now. What is the reading of the voltmeter? But here, unlike in the previous cases where we said R is infinity for a voltmeter, here we give the resistance of it. That means we should consider current to be flowing in it. So that becomes one more resistor as well. That's all, and rest is all normal. Tell me, children. If I give a little time, will you get the answer?
Yes, sir.
Okay, let me see. We need to once again check how to bring the current from the cell and divide it and see whether current is dividing or not, or potential difference is dividing or not. And then you will decide the series parallel thing and then apply the formulas and get it. Okay, the first time should have been over by this time. So if you think current is coming out like this, it is dividing into these two and joining once again and going like this. So aren't these two in parallel first?
Yes,
Should
sir.
we not reduce them to a single resistance? Huh?
Yes, sir.
So how much is that? 100 into 50,
By 1.
150. 100 by 3. That is in series with 50. Isn't it so? So 100 by 3, this is solution for 8, this is solution for 7. So 100 by 3 plus 50. How much is this?
250 by
250 by 3. Therefore, the current from the cell will be current from cell or current to the cell, both you can use. 125 divided by 250 by 3. So how much is it?
3 by
3 by 2. Now once that 3 by 2 comes, it will divide. Or you did not even bother about dividing in this case because you already know the equivalent resistance of 50 and 100. How much is that? 100 by 3. So put together, how much current flows in that? 3 by 2 only, right?
yes.
So the potential difference between these 2 points is what the voltmeter reads. It is same for this and this. What do you say, children? So I can straight away use that 100 by 3 into 100 by 3 is the resistance of these two things put together. Okay? What do you say? Into current is how much? 3 by
3 by 2.
50 volts. But somebody wants to divide and do, you can still do, I have no problem. 3 by 2 divides in which way, children? 3 by 2 goes as how much in 100, how much in 50? Into how much it goes into 100, 3 by 2. 3 by 2 current is coming like this, right? So in what ratio that should divide? Resistance ratio is 2 is to 1. So current ratio is
1, 2.
1 is to 2. So into 100 if you want, how much is that? 3 by 2 into, tell me, 1 by 3. 1 by some of the ratios. 1 by 1 plus 2. 10th class thing, nothing more. So what do I get? The current as 1 by 2 amperes. So 1 by 2 into R is the potential difference. So 1 by 2 into 100 is what? 50. R, how much it will go into this? 3 by 2 into 2 by 3.
1 amp.
1. So 1 into 50 is 50 again. So whichever way you do, that will be 50 across 100 ohms. Now, if I remove this and connect across 50, what will be the read? That you do and tell me now. This voltmeter is removed from here and connect across that 50, this side 50. So how much will be the reading of the voltmeter? It reads
70.
potential difference. Huh?
75.
75. No. It cannot be. Come on, children, quick. Hmm?
Sir, 75 by 2.
75 by 2. When that looks to be not correct.
Sir, 100 up.
No. Anyone else? Array, if you followed this, why can't you do that? And that you can do it in the mind. Why should you actually write also?
25.
Hmm? What is going on?
25.
Sir, is it 25 volts?
Yes, 25 volts. Harshini gave it first, Dishita gave it next. It is 25. Actually, if you're smart, you could have guessed it. Okay, you can do and confirm your guess. Look, 150 without that voltmeter are in series, isn't it? Huh? 150.
Yes,
They are in series. So in series, potential will be dividing in the ratio of the resistances. For 100 it will be 2 times, for 50 it will be 1 time. But we connected voltmeter. The resistance of that is not changing there. Whether you connect it across 100 or connect across 50, that R equals 50 is not changing. So I could have guessed it. If it was 50 across 100, probably it could be 25 across 50. I could have guessed. Not that you should guess every time like this, but can you guess and estimate, but later prove it? So if you do without writing, let us do that. 50 and 50 are in series, right? I'm sorry, in parallel, isn't it? When you remove this from here and connect across the other 50, what is the equivalent resistance of this 50 and 50? Tell me. Come on.
25, sir.
25. 25 and 100 are in series.
Yes, sir.
How much is that?
125.
125. So what is the current now? 125 by 125. 1 ampere.
Yes.
So,
So 25 into 1.
25 was the equivalent there, isn't it? So
Yes,
25
sir.
is 25 volts.
1.
So what is there to do actually? Tell me. Array, don't make these problems look what you call IIT advanced problems. No, if you did not follow, I'll write it all over again. But what's the point? Why they're already coming? The time up. Okay, then all right. We couldn't do even 10 questions. There are actually more questions planned, but tomorrow we'll do. All right. But as I told you, if you want to improve your understanding, please go back and watch the recorded video again. Those people who think, sir, that's not clear, there's no excuse now. But the only thing is, it has to be done through the physics approach, conceptual approach, not remember some vague logic. Okay, I'll be closing this, and tomorrow we'll meet again. But I want you to look into the video again and tell me. All right.